All right, looks like everybody's about wrapped up. Lesson 12. Being able to figure out what kind of information you need. It says, what would you need to answer the following question? How many meter sticks does it take to equal the mass of the moon? What are some things we would need to find out? Yes.
You would need to know how much mass
Mass of what? The moon. Yeah, absolutely. What's the mass of the moon? What else?
how much is the mass of a meter stick?
You bet. Mass of meter stick. Okay, if all these meter sticks were lined up, so if we had a pile of meter sticks, how long until they reach the moon? What are some things we need to figure out there?
How far the moon is first.
How far the moon is? Yeah, I guess length of meter stick, which maybe you should be able to figure that one out. Like a meter. All right, so let's figure it out. Question number 1. How many meter sticks does it take to equal the mass of the moon? Explain or show your reasoning. All right, so that information, some of you I saw were already Googling it. Said we need to know the mass of the moon. Here it is. 7 times 10 to the 22nd kilograms. That is the mass of the moon.
Pretty heavy.
Pretty heavy. Meter stick is 0.2 kilograms.
That's a lot of meter sticks.
All right, so if we are going to use scientific notation, both numbers should be in scientific notation. So just like the warm-up today, can you put this one in proper scientific notation for me? Remember, the decimal goes after the first non-zero number, which is a what in this case?
2.
2. And what's my exponent?
To the power of 1.
-1.
Negative.
Yeah, because that is a decimal number. You're moving the decimal to the right. It is -1. So we're going to use these two numbers. So we're going to take the big number, the mass of the moon, in kilograms, divided by the mass of the meter stick. All right, now to do these problems, you take the front number, 7 divided by 2. What's half of 7?
4.5. There, yeah. No, 3.5.
3.5. And do you remember what I do to the exponents when I am dividing? You subtract, so it is 22 minus a -1.
23.
That is 23. So that is how many meter sticks it would take to get the mass of the moon, excuse me. So 3.5, and then move the decimal 23 spots to the right. You can tell it's going to be a really large number. Next page. All right, so if we were to plot this, our exponent we said was 23. So we are going to increase it 1 for my right side. Remember how I do my tick marks from last week? 1 times 10 to the 23rd. 2 times 10 to the 23rd. Okay, go ahead and jot those in there all the way to 9. Please. Then put a dot where our answer would be. Okay. 3.5 is, of course, should be between 3 and 4. So put a dot there for our answer. Okay, so we needed 3.5 times 10 to the 23rd meter sticks to weigh the moon. Would that reach the moon?
Probably not.
Well, we would know how far the moon is away. The moon is roughly 3.8 times 10 to the 8th meters from Earth. So would that reach?
Yeah.
Yeah, we have quite a bit more, like 10 to the 15th times more.
So you said I could touch the moon if I get that many meter sticks.
Absolutely. Almost touch it there and back again.
It might be a pretty hole in my pocket, but
Yep, that'd be a lot. All right, about how much bigger is it? Well, same way we did the last one. If I were to divide those out, these two are basically going to be a wash. 3.5 divided by 3.8. I'm going to estimate and just call it 1. Subtract the exponents. This is how many times more you have, times bigger, if you will. Extra meter sticks, and that's a big number. That is like beyond trillion, like 100 trillion.
so I could walk to the moon. Meter sticks.
If you had that many. Yep. All right, question number 4. Gavin, why don't you read that one for me?
Alright, 1 light year is approximately 10/16ths of a meter. How many light years away would the meter stick reach? Like what number line and clock answer?
All right, so this would be 1 times 10 to the 15th. This would be 2 times 10 to the 15th, 3 times 10 to the 15th, and so on. And I have this many extra, and of course I will just plot that dot right there. All right, so let's move on from meter sticks and talk about cash.
Ooh,
My favorite.
straight cash.
Dollar bills.
I know.
Bottom of 88. Bethany, would you read that little intro, please?
In 2016, Burj Khalifa was the largest building or tallest building in the world. It was very expensive to build. Consider the following question: which is taller, Burj Khalifa or a stack of money it costs to build the Burj Khalifa?
All right, so which is taller, the Burj or what it costs to build it if you would stack dollar bills? What are some info we would need to know?
It costs about 1.5 billion.
Yep, cost to build. What else?
What type of bills you're using?
How tall? The height of the building,
What bills you're using?
and probably the height of a certain amount of money. You know, how much is $1 million height or $1 height or whatever. No matter what bill we use, it should be the same height.
Well, no, it's 100. Add up to your.
Right. Yeah, what are we stacking? Very good.
If you use a dollar bill, you can go to the top.
All right, so here's the info. 830 meters tall. $1.5 billion.
That's a lot of money. Jeff Bezos wishes.
And if you were to stack a $100 bill 1 meter high, that would be $1 million. So if you randomly see a stack of $100 bills a meter high, It's $1 million.
Might wanna take
I would grab it either way.
$100 or $1 million. I don't care.
Even if it was a stack of 20s.
I guess I should have wrote that up above here. The information. Okay, then it says, all right, let's figure it out. All right, $1.5 billion. Would look like that, so I'm going to put it in scientific notation just so I don't have to deal with such big numbers here. So somebody put that in scientific notation for me.
1.5 to the power of
1.5 times something, yeah. Power of what? 9. Move that decimal. 3, 6, 9 to go right here. Very good. Our bills. Put that in scientific notation as well. That would be 1 times 10 to the 3, 6. Now I'm ready to divide it again. We're going to divide the front numbers. 1.5 divided by 1 is, of course, 1.5. Subtract the exponents. 9 minus 6. 3. So stacking up the cash that it costs to build would be 1,500 meters tall. Almost double what the Burj is. All right, so let's put that number on the number line. If I want to plot 1.5 times 10 to the third, what number goes in the box?
A pretty big one.
Nope.
A 3.
Yeah, it should be one bigger than what we're trying to plot, so that should be a 4. And then 1 times 10 to the first, third. 1 times 10 to the 2 times 10 to the third, 3 times 10 to the third. Now we're rolling. Then plotting 1.5 would of course be between the 1 and the 2. What has more mass, the Burj or the mass of the pennies it costs to build? And what kind of information? I'll give you that. Here's how much the Burj weighs. Mass of a penny, obviously not very big. So top one is the Burj, bottom one is the pennies.
Probably like the pennies. Does somebody know the weight of the Burj?
Suppose we gotta figure out how much all those pennies weigh. So we had our $1 billion up here. What it costs to build. How many pennies would that be?
More than dollars.
How do you get from dollars to cents?
You subtract from $1.
So if you have $2, how many cents is that?
200.
200. If I have $1.5 million,
It's like a big number.
so $2, right?
Two.
You add 2 zeros to get 200 cents. $1.5 billion, I would add 2 zeros again. So we're gonna have to take that times 1.5 billion.
115 billion.
Times 100 to get the cents. So if somebody wants to run that number for me.
Gosh. $1,500,000,000.
Can you put it? 150 what?
It's got 9 zeros after 150.
150.
It's got more than 9 zeros.
So that'd be times 10 to the 11th. All right. So again, what is more weight-wise? Well, here's the weight of the burge. Here's the weight of the pennies it costs to build it.
Probably like the pennies.
Yeah, the penny's definitely bigger by 1,000 times. 10 to the third. So again, if I was going to graph that and I want to graph 10 to the 11th, I'd put 12 over here, one bigger. 1 times 10 to the 11th, 2 times 10 to the 11th, and so on. We've done enough of those. I think you got it. 1.5 is again between 1 and 2. All right, taking a look at your homework. Number 1, pretty self-explanatory. Just dealing with really big, small numbers. I would put them in scientific notation, all of them. Answer the question accordingly. Question number 2, you might say, where in the world are the questions? And again, bad formatting, they're all on the next page. Question number 3, there's a mistake there. See if you can find it and fix it. And question number 4 is a review of triangle angles there. So those 4 guys for tomorrow, 1 through 4.